Good afternoon, dear friends. Today I'll be telling about linear regression in R. So I'll be telling how to implement that in R and read the results and how to plot the residuals and then prediction. Okay, these are the topics I'll be covering today. So I have got an Excel file with the name age and height 1 and it has got a sheet with the name DET. So I will be reading this data into our R. So this is a command for that. Before that, you have to load the library read Excel and then you have to execute this command. So here this is the variable name age and height. You are using the command read underscore Excel and you are giving the name of the Excel file and then sheet name. So you can see the variable. A small warning will come. Just ignore that. There is a difference in the version. Okay, so you have run that Excel file into this variable age and so you can see age and height. If you type dollar and then you can see the different columns. Okay, suppose you type this, you can see the value. Okay, so now you're going to do the regression analysis. Okay, so what is a regression analysis? So regression analysis is nothing but a scatter plot. Okay, you can take like that. This is a scatter plot. So it's having two variables x and y. You're going to find the relation between that x and y variable. Okay, so I will just show you that. So just see. So there are two variables are there, age and height. So suppose we are taking age and height. How these two are related? So you are having a x-axis and y. This is the x-axis and this is the y-axis. So you are giving the values of age in the x-axis and height in the y-axis. Okay, so this can have a line like this or like down. So this relation. So this is called the regression analysis. Okay, so how you are going to find the relation between these two variables. So this is the independent variable. Okay, this can take any value and for this one x value you will get a corresponding y value. So this is a response variable. Y is called a response variable. So another example is if you are drawing for the diet you are taken and the sugar level. So diet you take will be in the x-axis and the sugar level will be in the y-axis. So this is called the analysis or regression analysis. So this is what you're going to do between two variables, mainly between two. That is a simple one. Between this what I told you is a simple case. Okay, the complicated case this is a simple case. So between two variables, that's what we are going to do. Okay, I hope it is clear to you. So this is the command for finding the model, linear model. Okay, lm command, lm, and then what are the column names you want to give here? Height versus age, and data is age and height, the variable where we stored the data copied from the Excel file. So now if you type lm height, you can see the result stored in that. So what you got, the first line shows the command that you use to create the linear model. Okay, this is a command. Okay, and now it has given two values, intercept and one value under intercept and one value under age. So I will explain to you that. So just see, these are the two values you got from this 64.928 and 0.635. So the meaning is intercept means the point at which the line meets the y-axis when age is 0. Okay, so the equation should be y equal to mx plus b. So here what are the y? Y is height. Height in our case, y is height equal to m into, okay, some value. M is a slope here, actually slope, m into age, in our case age, plus intercept. Okay, intercept value, that's a b, corresponding to intercept, plus intercept. Okay, so let us substitute and see here. Height equal to m is correspond to 0.635. Okay, 0.635 into age plus this value 64.928. So why you are using this one is because you can substitute any value for the age and see what you get for the height prediction. Okay, so that's why you are using this regression analysis. Okay, mainly for predicting for the unknown values. Okay, so these are the two. What are the two results you got? Two values. So one value that that comes under intercept, that is mean just take into account that line or our model meets the y-axis at that point. That's why our this model, so starting from 0, some 64 something like here means our model is intercepting the y-axis. Okay, so when x is equal to 0, it means at 64. So this is the meaning, and slope of this line is 0.635. I hope it is clear to you. Okay, so this is how you get the results. So now if you type, now you, how you got this, you just type lm height, then you got this. Now if you want to know the summary of this model, okay, you get the summary. So this is what I am going to explain to you. What are the, how to analyze the results. Okay, you got a, now what you did till now, you copied your data from Excel file, and then it had age and height. So you use that age and height to create a model, age versus height. You create a model, and that model is contained in lm height variable, and you have seen, you have called for the summary of that model. Okay, so you have got this one again like the before. The first line tells the command, and these are for the residuals. Okay, residuals means the difference between the, so I'll show you one more thing. lm height, okay, it has got so many value, so many columns, or so many values in that. Okay, so coefficients are there. Suppose you type coefficient, okay, it shows the intercept and slope alone. And then if you type dollar residuals, so we are going to find residuals. So just type residuals, and you can see some values, negative and positive values. So the attractive point of this is, suppose you made a model and you are finding the sum of the residuals. Okay, your model has got a residuals, it should be more or less equal to 0. So you can see this is more or less equal to 0. Okay, that is one property of the residuals if your model is a very good one. And now something else is there. I'm going to explain to you what is the residual. lm height dollar fitted values. So fitted values means you got a line. Okay, so actually your point will be outside the line. Okay, so now I will show you the plotting also. And this residuals is nothing but I'll show you. So this residuals you found minus 2.57 to 0.15. So for each observation, it has got a residual. So the residual is nothing but difference between the observed value. So what is the observed value? Age. Observed values are height. These are the observed values. Okay. Difference between these two will give the residual. Okay. Minus LM height $fitted value. Okay, you can see this will be same as this one. Okay, so this is what a residual. Residual means this observed value. Observed means what you had in the height in the Excel file minus the points in the model. That's a residual. Okay, so again coming back, I'm showing the summary. So this is telling about the residuals, but here the minimum value, first quartile value, median, third quartile value, and max. If you plot a box plot for the residuals, you can see box plot for the residuals, LM height residuals. Okay, so this values correspond to that. Okay, the maximum value is 0.4 something, and the median comes around 0, and this value correspond to the box plot values of the residuals. Okay, and coefficients same I told you, intercept and then m value, the slope, and error. These two are not that important. Error correspond to the precision in calculating the intercept. This value correspond, this row correspond to intercept, and this row correspond to age. Okay, so this t value is t value is this estimate value divided by error. Okay, t value tells how much far it is from the zero. So, but these two are not that important. Error and t value are not important in this case. But for you, the most important is this p value. Okay, you can see p value is very less. Usually your alpha is 0.05, or your level of confidence is 0.05 or 0.01. So here this p value is very small. So that means here what we do is that there is a null hypothesis and an alternate hypothesis. So null hypothesis always say there is no relation between age and height. Okay, and alternate is there is a relation. So here, since the p value is very less, you can go with the alternate. So you can go with this intercept and age. These values are very good. So this star correspond to here. Okay, this is more or less equal to 0. That is why the 3 star came. So it should be it should be less than alpha. Then only you can go with this intercept and slope. Okay, and other one value which very important is, see here when you do this linear model, you didn't get the correlation value. For getting the correlation value, you have to use the correlation command, COR command, and you have to age height $age comma age and height $height. So you get, so the R value or coefficient correlation. Okay, correlation coefficient is 0.99. So this is highly correlated. Okay, this how Pearson constant or Pearson coefficient. So this value is not got from the summary. Okay. And also suppose you want to know the number of observation, you can use the command length lm height $residual, so you can know how many observations or 12 observations are there. So suppose you had done the regression analysis in Excel, these two values will also be there in you along with your result, but here these two values are not displayed in the R. But don't worry, this you can find using some two different command. Okay, so here residual standard error means the standard error associated with the residuals. Okay, and degree of freedom means what freedom you have got in the residuals. So as you know, what is the degree of freedom? Usually degree of freedom is number of observations minus 1, and then other important one is multiple r squared. So r squared value. So here it gives 0.9888. That means 98% of the data is fitting our model. Okay, this should be very high. Then only it is our model is good. Adjusted r squared comes when you are taking more than one x variable. So if you are taking x1 and x2 and then you are comparing this x1 and x2 to y, so adding that one more x variable, how it is benefited. So in our case it is not that important, but we are taken only one x and one x. And f statistics you get from the variance. Okay, it's a ratio of the variance, and here also don't worry much on this f value, but you take care of this value. So this value should be less than your alpha, then only your test at your statistic or what you did now, this model is a good one. Here it is very much less than your alpha value, so you can go with this model. So this is what is known as regression analysis. Simple regression analysis. In now I'll plot and show you how to plot this model. Okay, I'll show you that. Yeah, see, these are the examples of r squared. So r square value, when it is very low, you can see the points will be very far from your model. Your model is this line. So suppose your model is as what we have got. Our model is our r square value is 0.988. So you can see the values. These are the observed values. Okay, the blue one. Observed values will be similar or very close to the model. Okay, and now so this is how you plot it. So plot this command to plot for the age and height. Okay, this one will come, and then you can add the model to that. This is how you add the model to this. Okay, so what are the points we covered now? Yeah, p-value, coefficients, and this much we, and residuals also we covered. What's the residual? So now I'll show you how to plot the residual, and rest topics also will cover. Okay, so this is a command for the plot residuals, and you can see here one point is has got very much height. So that is the third one, this value. So this is how you plot the residuals. Okay, so now if you want to know the most influential ones, okay, cook distance, lm height, $residuals. Yeah, yes, I'll plot that and I'll show you that smaller as let me see. Yeah, there was not to give the residuals. So this command alone was enough to show it. So which residual is the most influential ones? For that, you have to use the command cooks distance and then your course distance will give you these values, and then you can use the plot command and you can see which one is which is the most influential one. So changing this value, this may be a, so we can just see, we can see something, and age, height, I'm changing the value equal to 7.7. okay, so now let me if I try this, so now I have modified the value and I have put a 7.7 here. Now if you try the model, so I am going to make a model with that. Okay, I'm creating a model, and now if I, now you can see you can see these values would have changed. Summary, lm height, you can see here, just one value, changing one value has affected this. See, p values, everything will become very high, and r multiple r values became very low. That means 23% only fitting the model. And this one also, so there is no star here, stars has gone, and then the p-value is not less than 0.01 or 0.05. So this model is not fitting. So now let us try our Cook's distance. Okay, and then you can just plot and see whether which is more. Okay, see now 1 point that I had changed the second one too, so that is affecting the model. Okay, that is why everything has, all the values has changed. The even the median for the residual is not equal to near 0, and the p-values has become more than alpha. So, and when you plotted the Cook's distance, you found one value alone is affecting. So that value I had changed it manually, so that value is affecting the model. So now I think I have taken everything, only this point is remain multiple linear regression. So I will just take that also. That is how we are doing, is that we will take into siblings also. Now siblings, we had 3 columns: age, height, and number of siblings. So let us see whether we can make a model using the number of siblings column, and then let us see. Okay, so now we have added the one more column, and then let us see how our model fits that. Okay, and then you are typing the summary lm height 2. Okay, so suppose you take this, you can see here this value. Okay, so as before, this is correspond to the intercept, this is correspond to the age, and this is correspond to number of siblings. So you can see this one, the p-value is 0.879. that is much higher than the alpha value, so that column is not helping to interpret our, or not helping our model. That's why the p-value is very high. So, and the adjusted r-squared value, as you can see, it has come down. Before it was point. Okay, just type summary lm height, and you can see I had made this before by manipulating the one column. Just a minute. As you can see, I am reaching the value, and I have set now. So you can see that adjusted r-square value is also coming down. It was 0.9876 before, it has come to 0.9863. So adding this number siblings to calculate the height from the age is not good. That's what we got from this. So I think I have covered almost all. And now, yeah, prediction is also there. I'll tell about the prediction. So I've taken what the linear regression, what is it, or how to create in R, and then coefficients and p-value. These are only 2 important things I have taken. and multiple linear regression. So I added the siblings and then I told you this is multiple linear regression, 2x values, and then seeing whether it is helping us residuals, and then how good is our model. I told you to get from the F test and then other p-value and plotting and predict, and now predict one more prediction. I'll tell about the prediction. So this is how you do the prediction. You create a data frame, new underscore ages with the values of 12, 19 and 24. Okay, I'm just making a data frame with the values for age as 12, 19 and 14. Okay, so you can see what is the new dot ages. So it will have three values, 12, 19 and 24 corresponding to the heading or column name age. That's very important. The column name should be the same, and then you can use the command predict what's the model, our model, and then the new values. So you will get the values of the height as three values you get corresponding to the height 72.54. These three values. Okay, these three values correspond to these three values of height correspond to these three values of the age using the model LM height. Okay, so this is how you predict. You have to create a data frame, and suppose you want to change, you can give any value. I am giving 30 here. Okay, 30, and then again you can find the. Okay, so now this is corresponding to 30. Okay, so this is how you predict the values. I hope it is clear to you, and this I have taken in the simple way. In one another video I will demonstrate with a bigger database and see the complexities involved in the regression analysis of R. Okay, thank you.